All right. So the plan here is to go over lesson 6-6 homework. So I have no idea how long this video is going to be, but hopefully it won't take forever. Let's talk about problem 1. The height of a diver above the water is given by this equation, where t is measured in seconds. Seconds is the input from today's lesson. And h of t, the stuff you get out, is measured in meters. Select all the statements that are true. So before we even do that, let's go ahead and let's identify what each one of these is. All right, so we have a single non-variable. Non-variable is a constant, so that's probably our starting position. It's probably on the diving board. Although 3 meters up in the air is actually kind of tall. It's like 12 feet up. It's a really tall diving board. All right, we have a single variable, right? The 10 times t. Notice these are both additive, right? Because it's going up in the air. So this is probably the speed. Someday I will master this. All right, so this is the speed, and that makes this the t squared. This is the acceleration, and the acceleration is downwards. So the acceleration is almost certainly due to gravity. Gravity. Oh man, that's awesome. All right, so now that we know what each thing is, right? This is acceleration due to gravity, this is the speed, and this is where we're going to start. The diver starts 5 meters above the air. No, it doesn't. We know where the start is. The diver starts 3 meters above the air. Yup. The function has 1 0 that makes sense. All right, let's go graph this and see what we get. So negative t squared plus 10t plus 3. Y equals negative 5. We're going to use x plus 10x plus 3. All right, if you'll remember, the zeros are where it crosses the x-axis. So we have a 0 at negative 0.26, and we have a 0 at 2.26. This means that if this was a diver, I wish I could make a cool animation. If this was a diver, the diver's going to start, it's going to jump, and then it's going to splash down into the water. Before that, we have no idea. They could be standing on the diving board for 10 minutes. They could be climbing out of the water. We have no idea, but it doesn't make sense to the actual equation. This is the only 0 that makes sense to the equation. So the function has 1 0 that makes sense in this situation. Check, right? When they, I'm going to use text so that I don't have to guess, when they land in the water. The function that has 2 zeros that make sense in this situation. Well, if this one made sense, then this one can't make sense. The graph that h represents start at the origin. If you forgot what the origin was, the origin is 0, 0. That is the origin. Let's go look. Does it start at the origin? Nope, it does not start at the origin. It starts 3 up in the air. You knew that because that was the starting point. But we know that it does not start at the origin. The diver begins at the same height as the water level. Probably not, since this is given above the water level. So we're starting 3 above the water level. I assume the water level is at 0. So those questions are the same. They are not. Right? So that makes the only answers that were right B and C. All right, let's go to problem 2. The height of a baseball in feet is modeled by this equation. Let's quickly remind ourselves. 3, it's in feet. Ooh, let's pick a different color. Let's pick pink. All right, 3 is our starting height, probably a person. So this is where we're starting, right? This is the speed, 6 feet per, seconds, right? So this is our speed, and then this is gravity. Always gravity, the thing that you're subtracting out. This is the acceleration due to gravity. All right, we've got a graph. We've got a graph that goes with the problem too. So when does the baseball reach its maximum height? We know that the maximum height, and how high does it reach its maximum height? So we know that the maximum height is always given by the vertex, right? Max height is the vertex. Yep, it was seconds. So we can label where the vertex is, right? We'll use green all the way through. Why not? I have the life, I have the time. Let's do it. I'm going to use green all the way through. I'm going to have the vertex is going to be right here, right? When does the ball hit the ground? Well, it hits the ground when the height is equal to 0. Right? So that's going to be right there. We notice that it doesn't hit the ground here, and that a -0 doesn't matter. It's not important, right? Negative time doesn't make any difference to when the ball is. It doesn't make sense for this equation. So this is our height. Sorry, this is our only 0 that makes sense, and this is our maximum. So if we're using a text box, because why not? I can type. Our vertex is approximately, we're going to estimate, I'm going to say 1.9, comma, I don't know, just below 60. So 55. Right? So if that's our vertex, we have an x value and a y value. Our x value is our seconds, right? Because that's what we see is that we're inputting in. Our x value is our seconds. Our y value is looking at it over here, our y value is our feet, right? So if I say, when does the ball reach the maximum height? It's going to reach it at 1.9 seconds. If you said 2 seconds on yours, don't feel like you have to go back and fix it. 2 seconds is fine. Slightly less than 2 seconds is fine. If you said, here's the difference between the right answer and the wrong answer. If you said about 2, if you said a little less than 2, if you said approximately 2, or if you said 1.8 or 1.7 or 1.9, I know that you know what you're talking about. If you said 17 and a half, I know that you're confused. Or more to it, if you said 55 seconds, I know that you're confused. So if you said 60 feet, slightly less than 60 feet, 59 feet, something like that, I am totally understand that you know approximately what you are talking about. These are my numbers that I'm picking, but you can pick whatever numbers you want, in as long as they make sense. If you say 5 seconds is the maximum height, then I know that you don't understand the question, right? That's the difference between getting it right and not understanding the question at all. All right, when does it hit the ground? Well, just before 4 seconds. If this is 3.5, it looks like it's hitting the ground about, I can make the little squiggly sign, about 3.75 seconds. We could even say 8 seconds if you wanted to write less, right? About 3.75 seconds. Just about here is where it hits the ground. All right, that's the 0. Going on to problem 3. Technology is required. Go look up Desmos. Basically, everything I love in my life is that I can switch these colors around. That's a nice blue. Ooh, we'll go with purple. Okay, so 2 rocks are launched straight up in the air. The height of rock A is given by this equation, whereas the height of rock B is given by this equation. I hope you can read those equations. In both functions, t is measured in seconds and the height is measured in feet. Using technology, determine which rock hits the ground first. It hits the ground when h is equal to 0. So that should be wherever the 0 is. We're calling it a 0 in today's lesson, right? Wherever the 0 is, wherever the the x-intercept is. So let's go plug these in. The first one is 4, 30, 16. Oh, I was typing and nothing was happening. Y equals 4 plus 30x minus 16x squared. All right. And then y equals, let's go back and look, 5, 20, 16. Y equals 5 plus 20 x minus 16x squared. All right, so what we see is that this number has a 0 at 1.46. This blue graph, so the top graph, has a 0 at 2. So again, these are seconds. When does it hit first? Well, 1.46 comes before 2, so that means the green, or the second equation, is going to hit first. So which one hits first? This was rock B. So I'm going to say rock B. I'm expecting, if you want to type, to explain how you know that. All right, now problem 4. Each expression represents an object's distance from the ground in meters as a function of time, seconds. Which object was launched with the greatest vertical speed? All right, so all we have to do is we have to go back. We have to know which one is speed. Speed is always the one with a single variable. The variable squared is always due to acceleration, and the start is always the constant. I'm going to type that out one more time so that you have it sitting in front of you. So we have the constant, which is always the start. We have the single variable, which is speed. And then we have the quadratic, or the squared variable, which is acceleration. Let's bet that's spelled wrong. It may be spelled wrong. No judgments. Right? So we know that the constant is where we're starting, or the starting height, in any equation that has this distance. The single variable is speed. All right, so it asks, which object was launched with the greatest speed? The greatest speed is B. So B is the top answer. Which was launched from the greatest height? This one has the greatest height, so A is the bottom answer. All right, problem 5. We are building a pen for his rabbits. I have rabbits too. On the side of the garage, he needs a fence on 3 sides and wants to use 24 feet of fencing. The table shows some possible length and width combinations. Which should he use? So we're multiplying. So 8 times 8 is 64. 10 times 7 is 70. 12 times 6 is 72. 14 times 5, I'm going to let you finish that. So then your answer is going to be, which has the greatest area? Remember that area is equal to length times width. Do the math. Here's a pattern of dots. Oh, we know patterns of dots. So this is a pattern of dots relative to the step number. Notice that the input is the step number and the output is the next one. So I'm not going to ask how many steps does it get to be 100 dots. I'm going to ask, what is step 10? Input, output. You got this. All right, let's pick a new color. I don't know that you can see that color. Let's pick a new color. Who knows what the default is? Nobody knows. All right, complete the table. So step 0 has 3 dots. Step 1 has 4 dots. Step 2 has 7 dots. Without even looking at this table, right? The question is going to be, how many will there be in 10? So if we looked and we said, let's look at this little space right here, because I am seeing a pattern. It is growing as attached to here. What you should see is that there's going to be, the next one's going to have some number and then 3 more dots on it, right? So it's going to have plus 3 on the outside, and then we have 0, 1, 4, a 3 by 3, which is 9. So the next one should be 4 by 4, 4 by 4. Oof, that's so messy. 4 by 4. which is 16, right? So what will the 10th one be? Well, step 4 was 4 by 4. Step 3 was 3 by 3. Step 2 was 2 by 2. So I expect step 10 to be 10 by 10 plus 3. So then if I was making an nth rule, I would say it's going to be n times n plus 3, right? The function is this function, which is exponential because there's an exponent in it. This function is quadratic. We can find the values of this. It doesn't take very much effort. I'm going to find 1 for you. I'm just going to find 4, right? Let's change colors. So when we have 2x, so it's going to be 2x, and this is x squared plus 16. So when we do 4, we're going to have 2 to the 4th. I am positive that I have a good calculator. So I have 2 raised to the 4th power. That's 16. All right. And then I have 4 squared, which is 16, plus 16, which is 32. You're going to finish this out for 5 and 6. You can do it. Find the values. Yep. Will the values always be greater than the values of g? Will this value always be greater than this value? Of course not. We just proved that it wasn't greater. But as we get bigger, it's definitely going to get greater. All right, last one. Yep, last one. All right, Han accidentally dropped his water bottle from the balcony. Here's our equation. Notice how there's no pause for Dora to answer the question. What's missing, everybody? That's right. There's no speed, right? There's no single variable because he dropped it. He just kind of like knocked it off of the edge of his thing. So we have acceleration due to gravity, and we have our starting height, right? So we can complete the table if we wanted to, or you can graph it. Let's go ahead. I can let you complete the table. We'll do this one. We'll do it 1 second. So at 1 second, 1 squared is 1, times 5 is 5, 32 minus 5 is 27. So you can fill it in at 27, right? We're going down. Is the water bottle falling at a constant speed? Well, there's no speed and it's accelerating. How do we know? We can graph it. So we had y equals 32 minus 5x squared. The negative side means nothing to us. In fact, let's go ahead and shift x to 5 only. So then, and this can be 0. All right, so the negative side means nothing to us because we don't have a negative time in this case. So we knocked it out of the water. Is it going to be constant? No, it's not a linear equation. No, it's not linear. There's no constant speed. Also, you dropped it. You didn't drive a car through it. What time will it hit? Just after 2.5. So if we wanted to graph it, there's 2.5. Here's our 2.5. Here's our 32. You could plot those points, but what it's going to look like is it's going to look something like that. Right? There's no speed, and it just fell off of the end. All right, that video was 18 minutes long. Hopefully this helped. Hopefully you can go back and replay what you need to, and I will see you in the next class.